Thanks to PCBWay for sponsoring this video with some very interesting looking PCBs that we will get to in just a minute.
Hello everybody, I am Ben from Team Panic.
In this video, I'm going to give you a full breakdown of how to use PCBs to make the simplest and easiest weapons you can possibly make for ant weight combat robots. This is 150 gram ant weights. This video is going to form basically a spiritual successor to my easiest spinner tutorial video. This is the easiest spinner here. However, in that video, I put a weapon on this that was fully 3D printed with screws as weapon teeth. In this video, we're going to upgrade and update that, bring that up to being a PCB weapon system which should survive just that little bit longer and hit that little bit harder. To start with, we are going to need two pieces of information. Before we jump into CAD, before we do any design work at all, we need two pieces of information. The first is how long our weapon can be. And in this particular case, because we are running this tutorial robot, we have 105 millimeters diameter that we can have as a full weapon setup before we run into the actual wall of the robot. So that gives us our diameter, which we're going to take into Fusion 360 in just a moment. And the second thing we need to know is weapon teeth, because PCBs themselves are not going to make good weapon impactors. They are too light and probably going to break if they take a direct shot from someone or give a direct shot to someone. Luckily though, there are two different options for actually making weapon teeth here. We have a tools heavy but very flexible idea and a tools light but very inflexible idea. And either of these should work. In my first version of these, I went with the tools heavy and flexible version because I was building this fairly quickly as a test and I do have a decent number of tools at my disposal, so it was fairly easy for me to put this weapon system together. However, in this video, we're probably going to go with the tools light version as an example of what is possible with minimal tools. So what do I mean by either of these? Well, on one hand, we have just a strip of 3mm steel from my local hardware store. This is the tools heavy option because at a bare minimum, you are going to need a drill of some description, a hacksaw or other powered saw, and something that you can use to shape the metal once you have cut it. When I did the original version, I cut this with a powered cutoff saw. I then drilled it with a drill press and then finally shaped the parts together at the same time on a bench grinder. And the more tools you have with this method, the easier this method gets and the more you can mess around with the design and the more flexibility and freedom you have. This particular weapon, I couldn't build a weapon this small using option 2 today because these options are just way too large for any of that. I possibly wouldn't have got this as light either. So this is a good and probably the best option if you do have the tools and equipment available to you. However, as mentioned, we today are going to be going through and looking at option 2. Now, option 2 is to use anything small and metal that you can find at your local hardware store as weapon teeth. So I have two different options here. I have small hinges. These are 38mm long hinges. I also have these two corner brackets, which are 3mm thick and again, also 38mm long. This is about the smallest I could get mounting hardware or hardware of any description at my local hardware store. And I think it's going to be fine, especially considering that we have a fairly large space to put our weapon into and a decent amount of mass to do so, because this design was designed to have a fairly hefty weapon stuck on the front of it. So that is what we're going to build today, a fairly hefty weapon. Now, in choosing between these two, there is a couple of things to consider and a couple of things that I did consider. First and foremost, the bolt holes on these particular hinges are not in a great place for mounting a weapon system. A, they are too big. These are 5mm holes, which means we need 5mm mounting equipment, so bolts and nuts, which is going to add a lot of weight to the system. Sure, it's going to be at the end, but the hinges are already heavier than the angle brackets, and so to keep the whole robot in weight, we basically just can't have this amount of weight. And B, the other thing here is that these holes are very, very, very close to the edge, which means that to make a system that bolts into here, you're basically going to have something come right up to the very edge of the hinge, which means that the metal isn't going to be the only thing making contact, and that's kind of what we're trying to avoid in this particular case. So as good as these hinges looked on the surface and when I was in the hardware store, further consideration means I really don't like these hinges as the ultimate goal here. So that leaves us with these 38mm angle brackets. Now, these are a little bit better because they have 4mm holes or just under 4mm holes. Even with this version, you're going to need some tools. Here, I'm probably just going to hit each one of these holes with a needle nose file, just a tiny little file, just to round these out just a little bit more so they actually go all the way up to 4mm so that I can put a bolt through them correctly. The other thing here is that there is plenty of space either side, especially on one side, to have material that is not going to be hit when the spinner hits into something. I've decided that to mount these up, I'm going to have these as the mounting holes and then this as the actual weapon tooth surface, which means that I have all of this material that is going to hit before any given PCB is going to hit, and that is perfect. That is exactly what we want. So we are going to go ahead and use these angle brackets to make our design, which for anybody out there who is building one of these in Australia, these are angle brackets from Bunnings, which is a local hardware store, and you should be able to get these pretty much everywhere you like in Australia. The other thing too I will mention is that these actually don't look too bad in terms of fitting inside the space that we have. If I throw this down, you can see that this back arm here doesn't actually quite make it to the center point, which means that we will have enough space to have an arm in behind here, and everything should just work. So with those two critical pieces of information, it is time to jump into some CAD.
So now that I have my two questions answered and I know the basics of the design that I want to put together here, I have jumped over into Fusion 360. Personally, I think this is the easiest possible way to make these PCB designs. So we're going to get started by creating a sketch on the ground plane, pressing C to create a circle. In my case, building for guesstimate, I'm going to use the maximum diameter of 104mm. This gives me a bounding box in which I can now build my weapon and my PCBs out. Next up, we put a line down across horizontally out to the full radius of the circle. The hotkeys I've used for these, C for the circle and L for line. I'm also going to select that line and turn it into a construction line because that is basically going to make it so that it doesn't extrude when we go to extrude this shape later on down the line. Next thing up, I am now going to create my little angle brackets, and the easiest way I think to do this is to create a center rectangle, which is in the create rectangle, center rectangle functionality. Put the center of the rectangle on that particular line that you've just created, and then use the dimensions that you have taken from the actual piece. In my case here, the crossbar of this particular angle bracket is 10mm by 38mm. So I put those two things together and I get a shape up here in Fusion 360. But this shape is currently not good enough. It doesn't actually sit where we want it to sit, but that's fairly easy to fix. Hit D to get the dimension tools up, press one of the top corners of the shape, and then the circle itself. This will actually take a dimension to the center point, which is okay. It's totally usable. Make sure the dimension is between the center point and the corner at an angle like this. If you move the dimension around, you will get a horizontal. You don't want the horizontal, you want the diagonal like this. Then change the dimension itself to be the radius of your circle. So for me, that is 52mm, which I did have correct and I changed. And hitting OK will mean that this point is now right on the edge of that circle, which is great. Obviously, you could do this without putting the circle down to start with, but personally, I prefer to have the circle there just because it lets me visualize the amount of space that I'm taking up when I'm making out my weapons like this. Then I am going to finish this off, finish off the basic shape by creating a 2-point rectangle and doing another 38 by 10 and just selecting the other corner because I want this to be my tooth. Now I could, with this angle bracket, swap it around so this part here or this part here was in this side and make a much smaller PCB. However, putting this flat face all the way out as far out as it will go gives us the most momentum or rotational inertia that we can possibly get, which means a bigger hit out of the weapon. Next up, we need to put in bolt holes for this particular bracket. We don't need to care about the ones down on this face. Those are not going to attach to anything because I don't really need them to. So all I need is the bolt holes on this other face. So I'm going to go in here, create another line, which is going to be a center line all the way down the part like this. And again, click on that and turn it into a construction line. This is only going to be there to be the place that I put down my circles to make the holes in this particular part. And again, we're going to C to create a circle, and I'm just going to create a circle that is 4 millimeters because that is how big the holes are going to be. Again, I'm going to do the same thing kind of further down. And then once we've done that, we now need to dimension these and put the dimensions of them exactly where they're supposed to be, which the easiest way to do that is to measure them with calipers against the edge of the part and then add the radius of the circle. So the first one of these is measuring at 5.5 millimeters off the edge, which means it is actually 7.5 millimeters off the edge. So again, hitting D to dimension, taking the edge, taking the center of the circle, and then we're doing 7.5, just like that. That one is now dimensioned correctly. Next one up is 19.5 millimeters off the edge. So we're doing 21.5. So again, just with the dimension tool, and that should be 21.5. Bam. So just like that, we now have the hole spacings that we need to get this system work. And now it is time to design the actual shape of the PCB that we're going to be using. This is the kind of important part here. So we're going to C to circle again, because we need to start with the hole in the middle for the actual brushless motor to mount up to. In my case, I'm using an 1806 motor with a M5 bolt through the middle, so a 5 millimeter hole is exactly what I need. If you are going to be bolting onto a different motor, change this section up to be the correct bolt hole spacings for your design. But a hole that is not going through anything is not actually that useful to us. So I'm going to put another circle around the outside here that is going to be 15 millimeters. That is going to give us some circuit board as a baseline that this hole will go through. This 15 millimeters doesn't need to be exact. You can change that down or up as you like, making it as thick as you want it to be. Because these weapons are going to be quite heavy, I've decided I'm going to add a decent amount of PCB material around this one central hole so that I am sure that I have enough material in here and it's not going to just break on the very first hit. After this point, we need a shape, and that shape now needs to encompass, well, touch at least this middle circle that I've created, and then fully encompass these two bolt holes. We want material around both of these bolt holes so that they become actual holes in our PCB. The easy way to do this will either be to create more circles around them, which you can either do by creating a brand new circle like this, or using the offset tool. Offset tool is kind of nice because it gives us an exact sized thing that we can use. I'm just going to offset both of these by 2 millimeters. And part of the reason I'm choosing 2 millimeters is because I want a size of material here that, again, gives us a little bit of meat around the actual hole. And also, I don't want the PCB being further out than our actual angle bracket here. And if I measure that, I can see I've got 1 millimeter. So realistically, I could put this up to 2.5, or even 3, and 3 would be just on the edge of what I actually want here. So I'm going to put them up to 2.5, just like this, and then I'm going to use some lines to create points from circle to circle. So we're going to do tangent lines basically everywhere, and we should be able to do this simply by going down and creating tangent lines everywhere. And tangent lines are fairly easy to make because all you need to do is move the point around until you get this little tangent symbol pop up. You'll be able to get that on one corner per line, and then you can use the tangent tool in the constraints functionality to finish this off. Literally by clicking the line and the circle it needs to be tangent to, you will get a tangent just like this. Now this sketch is getting a little bit messy, but I can assure you that we are getting really close to having our actual weapon done and dusted. The only thing here right now is that we now have a big shape with a lot of PCB material inside it, and we don't really need all of this PCB material. So we're going to create some clearance, again, using the offset tool. I'm going to use the offset tool to grab the lines that I've created and offset them by a certain amount. In this case, we're probably going to do it about 5 millimeters here, because that gives us a nice thick amount of PCB material to actually get some use out of. And we're going to do that for the 2 outside lines. This needed to be -5 because of the way the outline tool decided to push that particular part. And in this case, we can actually use this other line that has already been created for the back of the bracket as our internal shape. So we don't need to create an offset for this back line. However, what I'm thinking, I'm just looking at this, this might not be enough. These are quite heavy weapon teeth, so I am going to up this value. Now, as you can kind of see, I am guesstimating a lot of my measurements and numbers here. I am not fully an expert on how much force these particular designs can take, so I am just kind of playing with my numbers a little bit as well. What I can say is that this PCB material is quite strong, and a little does seem to go quite a long way. These are also fairly cheap and fairly quick, so it might be worth getting a couple of different versions of these PCBs made, where you have different levels of thickness inside your part, so you have different strengths of them. Now, we have done basically one side of our design now, and to finish this off, it is actually fairly simple. All we do is go into Create, go into Circular Pattern, select everything that basically puts our design together, which in this case is actually quite a lot of different parts, lots and lots of circles for all of our different holes. If you click or double click on lines that made up a shape, you'll get all of the other lines in that shape, which is how I did these 2 rectangles really quickly and really easily. Then having selected all of those points, actually we need to select one more. There's this guy in here. And having selected all of those points, we then select the center point, which is the center point of our circle. Now, immediately, Fusion 360 makes 3 copies of this, which we definitely don't want. If we do 2, or 4, we do 2, we get another copy of it out the other side. I mean, there is nothing stopping you from doing 3. If you want to do 3 and have a triple-toothed weapon, you can absolutely do that. Same by doing 4. You can just keep adding these if you really, really want to. Personally, I am going to stick to 2 because weapon bite is still a thing that I actually care about, especially in an ant weight. So 2 is going to be all I do myself. Once you've got 2, hit OK, and that will create all of those lines out the other side. With that, we are going to finish the sketch. And then this is a little bit of a mess, but that is okay. From here, we're going to create the PCB shape, and I'm actually going to create the PCB shape and then extrude the teeth on top of that. And then if I wanted to, I could extrude another PCB above that again. But in this particular instance, we're not going to. We're just going to do one PCB and the teeth. So we're going to hit extrude. And we're going to find all of the pieces that we actually care about for this extrude, which in our case is all of the pieces that make up bar. and all of the pieces around all of the bolt holes here. So that is going to be our PCB shape, or at least the basics of it. Now, PCBs are 1.6 millimeters. They can be more or less, but 1.6 is a fairly standard size, as you will see when we get to the ordering section of this video. But here we go. That is our actual PCB shape. Now, those of you who have done some more mechanical engineering in your life will immediately see that there are some problems with this, and that is fine. We are about to fix those problems right now. Oh, we missed a piece in our extrude. We need to make sure that our extrude actually contains these. So we go down into our timeline and do edit feature and select this tiny little piece in here on both sides. Cool. Now that those pieces are selected, we can actually fix the thing that I was saying that the engineers amongst the audience will know, which is that sharp corners are a bad idea. Sharp corners give you stress riser points, which is points where the material can crack under load. So we're just going to round these out. Basically, whatever you like, just put a decent amount of rounding on them. I've put 50 odd in here just to kind of round this out and make this nice and smooth. We're then going to do the same for all of the internal corners here as well. And yes, you can absolutely do this rounding of corners inside the sketch itself. However, I personally find it easier to do it after the shape has been created. It just kind of makes life easier, for me at least. So there we go, that is 2.5. The big thing here is that the shape you round out in the middle here needs to be the same on both sides. So realistically, I should have just grabbed all 8 corners all at once, but you can do it in twos as long as you make sure that you do the same amount of rounding on both sides, which in this case is 2.5. So there we go, we have a nice looking PCB shape ready to rock and roll. As I mentioned, I am going to just very quickly get our sketch back and create the weapon teeth that are going to be appearing on this design as well, just so that you get an idea of what this all looks like. So here we go. Here is our very weird looking weapon made out of angle brackets, and this is what it's basically going to look like if I go in here and just change the physical material of this particular part and just kind of change the look of that. This is basically what this is going to look like, of course, with a whole nother PCB stacked on top. But that has actually gone quite well, I think, and looks actually pretty decent. It looks like it's going to survive. It looks like it's going to take a hit and give a hit pretty well. I mean, these angle brackets are massive, but they are the smallest things that I could find and kind of the lightest things that I could find. The hinges could also potentially work here, but as mentioned, they are heavier and the bolt hole sizings are a little bit weirder, so they might not be the best choice, hence why I decided to go with the angle brackets. Also, the hinges are more expensive than these particular little angle brackets. So to continue this process, we need to first save the design out, and then we're going to create a brand new sketch. That sketch is going to be at the top plane of our particular PCB here, and once that exists, hit P to project include and select the face, which should light up blue like this. Hit OK, and you should see a purple line appear around literally everything. That's exactly what we want here. And then hit Finish Sketch. No worries. And then we should have a brand new sketch in here, which exists and has, again, those purple lines going everywhere. Next up, we're going to go create and then create a PCB using either associative or independent, doesn't really matter. If you're planning on changing things around in the future, associative will mean that any updates to this file will update the PCB. If you're just thinking that you're going to generate this into a Gerber file and get it cut immediately, independent is probably fine for you. So we're going to choose this profile to make our PCB out of, and just leave our origin in the center. That should be fine for everything we need. Then we're going to hit OK. That is going to create a brand new PCB file. That is exactly what this is here. This is now a PCB that can be created and used. So first of all, you need to save this out. And then for the absolute simplest thing to do, you can literally just export this Gerber file by pushing to a 2D PCB, which generates the new 2D PCB. Making sure to save both of these. Okay. Once you have that, you can use Fusion 360 to generate a Gerber file by going into manufacturing and then down into export Gerber and then pressing OK and finding a place to save out the Gerber file. However, this is just the very basics here. If you have some extra time and some extra knowledge of Fusion 360, you can mess around in this PCB board and add silk screens and add copper layers and things to the actual PCB, make them a little bit nicer and maybe even make the next couple of steps easier, because the missing copper layers and the missing silk screen do make PCB manufacturing companies like PCBWay a little bit confused as to your request. Adding in even simple copper layers and silk screens into these boards will actually make the next couple of steps easier, but as you're about to see, you can absolutely just leave this shape exactly as it is with no copper and no silk screen. The other thing about not adding either of those is you minimize the weight. Adding copper and adding silk screen material does add to the weight of the PCBs, which makes them just that little bit heavier. It's not a huge amount, but it is something. Okay, and now I'm going to walk you through getting these made by PCBWay, because it is not quite as straightforward as you may expect, mostly because if you have done the very, very quick way of building PCBs, they have no copper and no silk screen on them, which will have PCBWay a little bit confused. So first of all, we're going to put in an approximate size. I'm basing this off of my Fusion 360 dimensions. It's not exactly accurate, it's within a few millimeters though, and that has been fine for me in the past. I'm going to make 5 of these PCBs because that is enough to make 2 and have a spare strut left over, which is totally fine. Everything else we're basically going to leave at defaults. You can, if you want to, choose different solder masks, but in this particular instance, I'm totally fine with the green. I like green personally, so we're going to run a standard green solder mask on these. And again, leaving basically everything else as the standard defaults. You can, of course, also change the thickness of your board, but in my experience, the standard 1.6 millimeter boards are perfectly strong enough, especially when doubled up. And leaving everything standard means that you're probably going to get your PCBs faster and cheaper than if you start messing around and doing non-standard stuff with them. We're already doing some non-standard stuff with them, but not enough to basically slow down the process of making these PCBs. And we're going to get click some calculation, and it will tell us our calculation. Of course, I need to ship to Australia. We're going to save this, and it will allow us to upload the Gerber file that we just created. And with that uploaded, we then just say submit order. And you'll basically be taken to a page like this where you have your orders sitting there ready. Of course, you do need to be signed in for something like this because they need to go through an approval process. And your approval process is going to be weird here. So submit it and essentially just wait, because you are going to get a message from PCBWay saying that the boards you have submitted are unusual. And here we go. I now have the message saying that the review was a failure, and the review was a failure because there was no top or bottom layers to my copper, which is exactly what I personally want, but of course to a PCB design and manufacturing company, that seems like an error. So to correct this, all we need to do is go to Contact Sales Rep and send them a message that says that this is correct and I have made a design without any copper layers or any silkscreen layers. Please proceed with the order. And with this first email or message sent back to them, things should get moving in the right direction. They may send you another message to confirm. Just confirm that yes, you do want this slightly weird PCB made, and they should move your order on through into the purchasing step. I'm not going to show you any of that stuff because that'll be revealing personal information that I probably don't really want out on the internet. So the next couple of steps from here are all pretty straightforward anyway. So complete the order, have it sent to your house, and we'll jump on into the build process.
Okay, a little while later, and now our PCBs have arrived. As you can see, I have 5 of them in just the bog standard of all of the options, exactly what I ordered from PCBWay. So again, big thanks to them for these. Now, we are only going to need 2 of our PCBs to build this weapon up. We're also going to need 2 weapon teeth, 1, 2, which again, those are just hardware store brackets. They come in not very much each, actually. And then we're going to need 4 M4 bolts and 4 M4 nylocks, which is what we have there. And then for tools, all we really need is the needle file that I told you about before. These come in little sets of just little actual detail files, which this type of thing would be perfect. And I highly recommend these for any kind of combat robot stuff, because finishing up 3D prints and bits and pieces, a little set of files like these are ridiculously handy. I have 2 of these sets and they come in handy every single time. And of course, we're going to need stuff to do up the bolt. So I have a screwdriver and a pair of pliers to hold on to those nylocks, and then we should be good to go. Now let's just do a quick dry fit here so I can show you how all of this goes together and how it all looks. So one goes there and one goes here. And then the other PCB goes on top, and then we have a weapon. Bam! Oh, that is so easy. Or at least it will be. We still need to file out these holes just that little bit to get rid of some of the flashing to make these actually M4 holes. I'm not going to bother about doing all 4. I'll just do the 2 of them. The other thing I found is that these are, I don't know, molded or cast or something, and they do have little bumps and notches on the front or on a face near the bolt hole, but they seem to be everywhere. And I have a bunch of these little brackets because I bought them in a set of like 10 or 15, and all of them have that, so they should be balanced enough as they are. I mean, I hand balanced the last lot of these that I did and still somehow managed to get a balanced weapon, so I don't think we're going to have a vibration issue with these at all. So just time now to get to filing. With that done, it is time for assembly. Now I am going to put my bolts in through the top and put the nylocks on at the bottom, because for my particular design that is going to work the best. Mostly because when I'm upside down, I'm going to be running on this weapon bolt, and what I don't want to be doing is having excess bolt stick down and be hitting the floor. So by having the excess bolt sit back this way, it's not really going to touch anything. I will tape down my motor wires before I use this robot. So those aren't actually going to hit anything, and they're just going to add a little bit of extra mass to the whole system. I really do need to get slightly smaller M4 bolts, but these are the ones I had on hand right now, and they will do the job. And in fact, what they're going to do is add just that little bit of extra mass to my weapon tooth and make it hit slightly harder. And as always with complicated projects like this, you don't want to tighten everything down until you have all of the bolts in place ready to go. So I have 4 bolts in place and the 4 nuts in place now, so I can start tightening down, but there does seem to be just that little bit of flex and give in this system. So what I'm going to do is I am going to start tightening these nylocks down. I'm going to get to them to the point that they're just barely touching on all 4 of these, and then I'm going to make sure things are aligned the way I want them to be aligned before actually cinching the bolts shut and finishing this whole system off. So with my whole system bolted up, I can already tell I'm going to have a problem with this because these two are not exactly the same. You can see a larger gap between the PCB parts and the weapon tooth on this side as you can on this side. This side, we have a much closer gap. So all I'm going to do, I'm going to loosen these bolts off a little bit. I'm going to stand the thing up a little bit differently so that the weapon tooth falls out a little bit further, and I'm going to tighten these things back up, and hopefully we can get them to be about the same gap, because again, this is a spinner. We want these things to be as balanced as we possibly can. But once that's done, it should be time to mount this. On the robot here, I have what I used for the other design as well. It is a just tiny little 3D printed spacer, which should slot right between the PCBs in here. It may actually be a little bit too big because I think my weapon teeth are just a little bit shorter than the old ones. That actually may not be a problem. In fact, we're going to run without it this time, and we're going to see if it would make any difference at all. So we're going to slot this over the top, and look at that. We are perfect. We have just enough space in our design that nothing touches, and everything is going to work just fine. And there we go, weapon complete. Now, I did print a brand new little spacer to sit in here because tightening this down, the PCBs flexed a decent amount, and I was a little bit worried about that and worried about how well it was all going to hold together. And I've also thrown just a little bit of tape over the wiring along the carbon fiber drone arm down here. And we are sitting at exactly 150 grams, which is perfect. If I'd cut these bolts down a little bit more, I would have had some more weight that I could have played with to maybe put a slightly better top armor on here or something. But for now, that is perfect. So let's throw it in the test box. Wow, that was absolute carnage. This old PLA chassis has been entirely obliterated, so much so I'm getting junk out of it just by turning it around in my hands. That was very, very impressive. It hits really, really hard. The whole thing has held up well. Nothing is loose, nothing is spinning. It all worked out quite well. I do think my battery potentially has gone a little bit flat because this is a battery I've been using for testing a little bit. So the hits at the end weren't quite as good as they possibly could have been, but oh wow, that works spectacularly. This system is amazing, and I hope this helps you out there build your very first spinners and get into combat robots as a hobby, because this is good fun. And as you can see, now it's even easier to get in and run with a particularly nasty spinner, as it turns out. At some point in the near future, I will fight this robot in an actual competition because I feel like I have to at this point. It worked too well not to. So yeah, look out for that. Subscribe if you want to see that, and I will see you in the next video.